They are also, from a taxonomic perspective, they're of the mammalian order Chiroptera, which is sort of interesting. It's Greek meaning hand wing. Again, sort of to bring sort of the mythology and sort of conceptualism of them down sort of to earth. There's this great diagram here on the left that you can notice that they have all the analogous arm and hand bones found in, for example, a human being. That they're just arranged in slightly different ways and elongated in slightly different ways to give them sort of the morphological and flight capacities that they have. They are the only flying mammal, and as such are just utilizing a lot of the same body parts that we have, just in different ways. Regarding diversity, species on the planet, there's roughly about 1,400 of them. That makes 1 out of every 4 mammal species on the planet a bat. So there's a significant number of them around. Specifically, you may be asking here in the Northeast how many we have. I've got some little mug shots here for you. There are in Vermont anyways, there are 9. One of them, number 3, the Indiana bat, is not found in New Hampshire. So New Hampshire has 8 species. I've categorized them here for you in sort of these rough groupings. And again, this will play a role as we get a little deeper into discussion about the types of strategies that are used during winter. But the upper sort of 6 tend to be cave species, utilizing caves both in summer and during the winter as habitat. Cave, quote unquote, can be a relatively broad term, since with the number of people on the landscape in this era, buildings, barns, bridges, and stuff like that can have very cave-like characteristics too. But then there's the other category of bats, and in particular, this will come up, I'm sure, in Eran's talk, but the tree/migratory bats tend to be longer winged, longer distance flyers during the migration period. Most of their life cycle occurs in sort of the forested areas. The 3 on the images here on the bottom are the silvered-haired eastern red and the hoary bats. So 9 species total can be expected in this area. For diet, globally, with 1,400 species on the planet, there's a lot of different ways bats make their living, and everything from fruits to vertebrates like frogs and fish, to pollen and nectar feeding bats that take advantage of that. And there's a sort of a bonus question here in the lower right corner. There isn't a hint as necessarily as to what that bat eats, but maybe people can put it in the chat if they want to, what they think that is, and I'll talk about it at the very end. So the lower right bat is the one I'm asking about. But all that amazing diversity and all those bats in different ways they make a living, and all the ecological services and roles they play in the planet, what we focus on most in the Northeast in particular, and actually most of the lower 48 for the United States, is the insect-eating bats. On the planet, 70% of bats utilize insects or arthropods for their food. Here in North America, there's really only 3 or 4 species that don't, and those tend to be the pollen and nectar feeding bats down close to the Mexican border. So insect feeding bats are far and away the majority of reliant diet bats, and in particular here in the Northeast, that's all we deal with is bats that rely on insect prey for food. To give you a really quick sort of round the year idea of how bats make a living, so that we can put winter into the context and what role that plays in their life cycle. We're going to start here in autumn. Autumn is when courtship and mating generally occurs. There's some variance that goes on here, but that's the bulk of when this type of behavior occurs in bats. Winter is when we're talking about different strategies we're going to talk about in a second. We're going to go into in a lot more detail on those. Spring is again when they, as you would imagine, they wake up or come back from migration to come back to their summer roosting grounds. We have fertilization and implantation. So you have mating in the fall and fertilization in the spring. So there's quite a delay there, which is pretty unique and different, certainly from maybe a lot of the mammal species that we're familiar with. And that's done specifically because of the stresses and strains that winter applies to them. They want to be in their best condition possible when they go into the fertilization implementation stage. So they actually purposely, they want to be in their fall condition for courtship and mating because that takes a lot of energy, and they want to be in the spring mode for fertilization and implantation so that the females know that they have the body condition suitable for reproduction that year. So some pretty amazing things that, again, have to do with winter and how they're handling winter. Right after spring and fertilization implantation, they're going to be moving into these very specific areas. These are sort of the maternity bachelor colonies. They're sort of the antithesis of winter hibernacula, which we'll talk about in a second, but they're sort of the opposite. They're selecting very hot environments to raise. You can see a baby bat there on the finger. They are very eyes closed, no fur, very relatively underdeveloped. And so they rely a lot on both the mother and also the environment that they're born into, hot attics. And for those of you who've had bats in barns or their homes, the reasons they're selecting those really hot environments are specifically to help raise their young. So a lot of temperature requirements, and you'll hear that theme as we continue this conversation about winter. Birth is generally 1 to 4 babies in these maternity colonies. Very slow reproducing bats. They replace themselves at a very slow rate. Soon after birth, a couple weeks after birth, they're already sort of testing flight. And it's because they immediately have to start putting on some weight to immediately go back into their winter and fall. So from being born in summer, you're looking at flight and then dealing with winter within a few short months, which is a pretty tight turnaround for a young bat. And they will often do this up to 20 times. So bats, although they have slow reproductive rates, are really relatively long-lived for their size. And so, 20-year-old bats is not all that unusual, but maybe a little bit towards the top end of things. So pretty amazing life cycle. But so that gives you sort of the general idea of sort of a year in the life of a bat. Let's talk a little bit more about winter at this point. So as everybody's hyper aware, looking out the window right now, winter, results in 2 dramatic things. One is extreme drops in temperatures outside, and with a drop in temperature, particularly because we're talking mostly about insect-eating bats, or completely about insect-eating bats, we have basically the food resources go away for these particular animals. So the question is, what can you do about that? And bats really there's a lot of strategies, but the 2 or 3 main ones we want to talk about today are the migration strategy, the hibernation strategy, and then it's interesting to talk a little bit about the hybrid approach that a lot of bats take too. We're going to talk a little bit about costs and benefits. This idea that there's reasons why all species don't do this, and which one that's good to pick, and what the costs are of picking these particular strategies. The other thing I really want to highlight with you guys is that, honestly, this is only 10, of the 1,400 bat species on the planet, a very small percentage of them have to deal with sort of the temperate environments. The species diversity is much higher towards the equatorial parts of the planet, where it stays warm and food stays relatively abundant year round. There may be small migrations to follow food eruptions and food like flushings in the plants and those sorts of things, whether it be fruit-based or insect-based. But for the most part, true migrations and hibernation bands actually affects is relatively rare on a global scale. It's just a small number of the species have to take these extreme approaches, which make them even more interesting, I think. So talking about the option 1 specifically about migration, again, your temperatures drop precipitously, your food supply basically dries up. And so one option to fixing this is, make the temperature rise again and make your food come back. So how do they go about doing that? Well, it's not, some of you winter snowbirds may relate to this, but one of a great way to deal with winter is just travel south, right? Your temperatures come back to an environment where it's easier to make a living, and the food is also is abundant in these areas. So if you have a cold winter, go to where the winter isn't cold. Sounds like a very simple solution, right? Some fun facts about bats and migration in particular. There's different different ranges. Different bats are more or less cold tolerant based on body size and other factors. So you have some regional sort of migrators. You're talking about 50 to 300 miles for a migration. To give you some idea, that's like a Vermont to Maryland. You have other species that are migrating much longer distances, 600 to 1,000 miles. And to give you some idea there, you're talking about like a Vermont to Florida or something like that. These are some pretty general numbers, both for the distances and speeds, but the literature is showing on average that you can expect maybe 30 miles worth of migration per day for a particular bat. And it starts relatively early, maybe earlier than you would expect it to. If some of you are more familiar with birds and bird migration in response to winter, bats have started migration in some cases by mid to late August and into September even. So it's occurring very quickly and a little bit earlier probably than you would expect for even some of the bird species. And then one last really fun thing was that it can be very sex biased. And then by that, I mean that it generally tends to be the females are either by species, either more apt to migrate or even migrate a little further or have more dramatic migrations than the males do. It isn't just that they're always like traveling in pairs or even traveling if you're male or female. It matters if you're male or female and what the behavior based is. So migration is a more common thing among female bats. And in particular, they have more dramatic migrations in a lot of cases. Now, the trade-offs, I told you I'd talk about trade-offs, these cost balances. And again, you're looking at a trip that you're traveling, let's say a longer distance migration down the entire eastern seacoast. You've got a lot of things to contend with. One of them is that you need to maintain your health along the way. And that has a lot to do with even feeding conditions. So, for a species that spends its entire life within a couple square miles, you just have to worry about maintaining proper habitat quality for that species in those small areas. Anything with a migration, and this is an issue for birds too, if you're traveling really long distances, a significant enough amount of habitat needs to exist along that entire migration corridor. If you have a long enough gap where the habitat isn't significant, it can be a bottleneck to migration events. And so it really sort of raises the bar when you have migration that you're reliant on healthy and safe conditions for a very large area. And that can be really complicated in sort of our modern world. And three of the things that complicate that are these other pictures. Eran's going to talk a lot more about wind. But the turbines get a lot of press, especially the ridgeline turbines, where ridgelines are popular migration corridors for both bats and birds. They can provide a physical hazard. Light pollution is a big issue. So you're talking about a night migratory species. Additional light makes it a lot easier for aerial predators like owls and other things to be able to actually see bats as they're migrating. And so that becomes more of an issue. And then, of course, just general predators all along the way, raccoons, cats, those sorts of things can be an issue. So you're really putting yourself at risk in migration. It isn't all about just traveling to your southern beaches, enjoying your drinks with umbrellas in them. There's a lot of dangers with regards to migration itself, let alone the fact that your wintering grounds where you're going to land has to be in good condition to sustain you as an individual throughout the winter period and give you the weight and the body condition to make that trip again back north. So a migration is two of these long trips, not just one, because you're going to return again in the spring. So there's a lot of costs there. The second option that I wanted to talk about is hibernation. And this is a totally different strategy. This is sort of a shelter in place kind of thing. Hibernacula are the term for sites that bats use to meet their sort of physical requirements during the winter. So again, we've got the problem that we're trying to solve is drop in temperature and lack of food. Hibernacula sort of help assist with those roles. Now, the big picture here are like caves, mines, rock crevices, those sorts of things. To some extent, trees and some buildings can also act as hibernacula here in the Northeast, but to a much lesser extent. And I think it'll become apparent here in a second as we talk about what role hibernacula play, why the underground sites tend to be more successful and more selected for our local Northeast species. So let's break this down, how hibernation works. So you've got two problems you're solving, temperature and food, and basically energy. And basically temperature is, this is metabolism. This is your burn rate. So you're looking at temperature is sort of the dial, the control dial for how fast your metabolism is going. Humans tend to keep their body temperature at 98 degrees. So we have our furnace burning at the same, rate all the time. And so we're using relatively consistent amounts of energy. If you go out for a run or get some exercise, you're increasing your metabolism, you're turning up the furnace, you're burning more calories. So the whole idea, if you want to be able to deal with slower metabolism, burn less energy, you're going to need to really change your temperature to lower that down. So basically the temperature, body temperature is the number one thing to help affect metabolism. And also the amount of time. So in the case of the Northeast, we can be looking at up to 6 months of lack of food. So that's a really long period of time that you have to store that energy up for. So bats accomplish this by lowering their body temperature dramatically. We're looking at typical body temperatures of the upper 90s, low 100s, and they're lowering their body temperature down to 35 to 40 degrees centigrade, or Fahrenheit, excuse me. And that's a pretty dramatic change. And they also do it in a way that they don't have to spend energy to do that. They are picking and selecting sites very, very specifically, the environment that they're sitting in, that basically they let the environment set the temperature for them. And so site selection of their hibernacula is really important. The hibernacula itself is the 35 to 41 degree range. Then you can they can let themselves go in some ways to get to that temperature and not have to spend energy to be there. If the hibernacula is too cold, they've got to burn a little bit of energy to maintain their optimal temperature range. If the hibernacula is too warm, their body temperature will be too high and they'll be burning too much energy. So in either case, if the hibernacula is too cold or too warm, they end up burning more energy than they need to. And then doing the sort of little formula here that'll reduce the amount of time that they're able to stay in hibernation without going through the amount of energy that they've stored. So in addition to the body temperature drops, you're looking at heart rates dropping to only 5 beats per minute, and they can be taking a breath as little as once every 15 minutes. So pretty spectacular change from their operating speed during the summer. The other thing is food. So this is sort of how much gas is in the gas tank. You can talk about how fast you're burning it, but you also need to talk about how much energy that you have to burn to begin with. So they're balancing these two things. They're balancing the metabolism, how fast they're burning something, and how much they have to burn. A typical small myotis, one of the more popular genuses here in the Northeast, tends to weigh about 5 or 6 grams. Which is about what a U.S. quarter is, up to 15 grams. So just for size, you can think of a U.S. quarter. Prior to either a migration or hibernation, they're going to have to put some weight on. And they tend to put on almost 25% of their weight before they go into a winter. And that's their reserve to be able to burn during that winter period. And it's spectacularly enough, there's some studies, particularly with myotis, that they're putting this weight on in a really, really rapid fashion. In some cases, it can take them only 11 days to increase their fat reserves by over 900%. So again, there's sort of a feast or famine type strategy here, but they put on a lot of weight in really short order in order to either go on migration or go into hibernation. Again, like I mentioned, location. Caves and underground areas have in some cases, a lot of variability. If it's a very simple system, it may not have that really specific temperature range that they're looking for. More complicated systems are more usable to bats and generally have larger colonies. It isn't such a thing that bats just go to sleep for an entire winter and never wake up. They've got to pick a site first thing in the winter and just be right that in January it'll still be at the right temperature. Bats will rouse themselves and move around inside their winter hibernacula. They only get so many arousals per winter because every time that they rev their metabolism back up to become active and move even a few feet down a cave wall to either go deeper to where it's warmer or shallower towards the entrance to where it's colder, they're burning some of that energy. And again, it's that mathematical formula. You have so much energy and you're burning it at such a rate. So they're trying to balance all those things all the time. So, particularly complicated cave systems, which are relatively rare in the landscape, offer a lot of those humidity, temperature levels, all that variability that depends on how cold the winter is, how much airflow there is. There's a lot of selection that goes on. And on a very micro scale, they're being very specific and very measured about where they're selecting to roost. Now, what are the costs of hibernating? You might think, well, this is better than migrating. You don't have to take all these risks and fly all the way to Florida and have things, grabbing you and stabbing you and chopping you up in wind turbines. Well, there's a lot of risks having to do with hibernation too. As you can see, it's a really narrow metabolic rate, so it's really easy to get that wrong in some ways, in the sense that you can either run out of energy too early and have nothing to eat. There's also the idea that this is disturbance. You're concentrating very large numbers in some cases of bats. These hibernacula are of ecological very, very high importance because there's so many bats at these sites, that disturbance, people getting into them and walking around and wanting to cave and stuff like that, can be enough to rouse the bats and cause a lot of problems. So the whole idea of bat gating and that thing, like this upper left picture, is there to protect the bats and make sure that they have undisturbed environments. Even is something as little as a person walking through a cave, their body heat is enough to warm a bat up enough that it may arouse itself. It may not look like it, but a half hour later, that bat will become awake and move around, and that dramatically affects its survival for the winter. Predators are an issue in caves also. So, a bunch of basically food resources, everyone's got to eat. So there's, food resources like hibernating bats hanging on the ceiling can be food for other species. So that's an issue. And when you're sleeping, you're not able to defend yourself very well. So again, selection of where these bats are roosting their sites, generally why they're on the ceiling and not curled up on a ball on the floor. All these, there's reasons behind why nature does what it does. And then this last thing here, these last two pictures, is the white nose syndrome, which many of you have heard. It's dominated bat news for the last 10 or 12 years. It's been an incredibly detrimental, damaging thing for bats. And in particular, it's affected a lot of our cave bats. White nose syndrome was actually discovered near Albany in 2006, 2007. This is in North America. The fungus that causes white nose just loves cold, damp areas. It's native to Europe and Asia, and was just found in the US here in 2006, probably moved with recreational cavers or that sort of thing. But since then, it's spread very dramatically. You can see color-coded here. The very first years it was found was purples and blues, and then as it proceeds all the way up until November of 2022, which is the reds, you can see it moving from east to west and from northeast and southwest. It's affected a dramatically large number of the population, bat populations. And you may ask, well, what effect is that having? Well, here's that list again of our cave bats and our migratory bats. And unfortunately, this is what our state and federal listing map looks like right now. And you can see that there's a dramatic pattern here, that primarily it's the cave bats that are either under state endangered or in some cases federally endangered, proposed for listing or under review. We've seen in some cases 90% population drops as a result of the fungus arousing bats. It basically makes them uncomfortable and itchy, makes them wake up several times during the winter, and essentially they burn up more energy than they have stored to make it through that winter, and so then perish. A lot of times you'll see them even come out desperate for food or water during the middle of the winter, and of course there's nothing there, and so they die. So pretty sad stuff. There is, on the brighter side, there's some evidence showing that there is some resistance. Like most things, nature is resilient, and that the populations that are surviving tend to be a little bit genetically more predisposed to being able to deal with the fungus. So there's some resiliency showing in the populations, but they're at a very, very vulnerable state currently. And so in particular, winter ecology, the hibernacula themselves, protection of those and protection of the species during the spring and summer months has been raised to a very high level nationally to try and protect these reduced populations. So not to leave on a really low note, I wanted to talk about one last thing, and that is, again, the theme of resiliency. There's a lot of hybrid approaches to these two. This is a very oversimplified view of winter ecology with just migration and hibernation, and that's it. There's lots of different variances and hybrid approaches between these two on how bats in particular deal with drops in temperature and drops in food. You have some that will migrate very short distances to, again, go to a hibernacula, so where they're migrating to go go hibernate to find areas that are more suitable to them. We have species also that hibernate and for short periods of time in leaf litter. The red bat here on the right is an example of that, where leaf cover and snow cover is really important in the winter because they'll go into short bouts of hibernation, not for the whole winter, but periodically, where they'll migrate far enough south that the winter is a little bit milder, but then during cold snaps will go into deep leaf litter to maintain their temperature, basically like an extra blanket or insulation blanket, and weather winter cold spells that way. So you have sort of short migrations, short hibernations, mixes of hibernations and migrations, all to sort of solve this problem. And again, nature in general, but bats in particular, have a lot of really, really neat strategies associated with that. And I was happy to be able to share a few of those with you today. So that's my half. Stop sharing. I think I see a share button. I don't see an unshare button. Oh, here you go. Got it. So, Eran, I think probably you're up next.
Yeah, if anybody wants to maybe ask questions now before I begin.
Dangerous.
And if there are no takers, I will start sharing my.
Yeah.
Okay, so share. And I think it's okay.
Actually, I have a question. I just don't know how to enter it.
Sure. Go ahead. Just say it.
Yeah. It was said that the bats are courting and mating in autumn, and then let's say 6 months later, there's actual fertilization and implementation. How does that actually happen? I mean, isn't that what courting and mating is? I mean, not necessarily fertilization, like, fish or something that have eggs that get fertilized, but I don't understand that.
Yeah, that's a totally fair question, and I'll keep this family friendly. But so there's a lot of different strategies here. Obviously, the mating process is you're depositing sperm, you're giving the males are giving their genetic half to the females, and then you actually have to have the meeting of the two genetic materials, the sperm and the egg. And so there's lots of different places along there that can be delayed. One of the primary ones is what's called sperm storage. So the female will actually hold the sperm in a small pocket in her uterus for the entire winter, and then come spring, release that sperm and bring it into contact with the eggs. There is other strategies, delayed implantation, where you have the sperm and the egg meet, but then you delay implantation and growth of those systems. So there's a couple of places that you can sort of stall those sort of the meiosis and the division of the cells along the ways. But the primary one is sperm storage.
Thank you.
Yeah.
Can I ask a question also?
Sure.
So we have some bats that have been roosting in the attic. Apparently, they judging by the scat that's up there, it's too big for mice, and it's all along the ridge line where just below the ridge line of the roof. We just put in an attic fan because it was getting so hot up there, and now I'm wondering what temperature should the fan come on at in order not to kill the bats.
So you want to keep bats up there, or you want to get rid of the bats? The temp,
Well, I don't mind having bats up there. We actually have a bat house up there, and they don't seem to be using. So I'd rather they went there, but I'm not going to chase them out of the attic.
Yeah. I mean, the general recommendation is certainly to keep bats and people in very separate environments. Generally, having bats in your house is not a good idea. They do have a tendency to carry, they're a known rabies carrier, which is an incredibly, dangerous disease. And so the idea of, bringing people in close contact with bats, particularly in living spaces, is generally not a good idea. So for all intents and purposes, you should do what you can to prevent them from entering your home. And to that means generally it's, you tend to block areas that they're getting in and out. The ingress and egress areas tend to need to be closed up to prevent the bats from getting in. Certainly reducing a lot of times they're using those hot attic spaces. It tends to be the females, and it tends to be summer or the maternity colonies. I mean, males don't want to be sweating it out at 110, 115 degree attics, right? The females do that specifically to put themselves in a situation where they can leave their little pups at night and go out and feed and come back. So if you have maternity-like colonies in your attic, you could, I suppose, make them less palatable by installing a fan and keeping the temperature in there lower. For the general numbers that I've always seen batted around, sorry about that bad pun, are between 97 and 100 degrees for body temperatures. I would imagine if you're looking for specific temperatures, you wanted to keep an attic under that would make it unpalatable to a lot of bats, at least for maternity use. I would think if you could keep it in the low 90s or below, that would probably be suitable.
But that's the opposite of what she asked. She's asking how not to
How she
destroy the
wants,
bats now.
yeah, and I just can't,
Well-
I can't really offer opportunities for how to increase the number of bats in your attic. That's probably just, I think that's generally not something that we want to recommend.
Yeah, and the other thing is, are they like mice? Can they get through? I've looked and I don't know where they might be getting through. So can they get through like a half-inch hole like a mouse?
1/4 inch to 1/2 inch, yes.
1/4 inch.
Yeah.
Okay.
I'll offer my pun. There's a thumb rule there. If your thumb can go through it, the bat can go through it.
Excellent. We can take some questions at the end too. But yeah, those both were great questions.
All right, so I'll start, and thanks for inviting me again. And my name is Eran, and I think this is different than what I usually give in this workshop, and I'm going to talk about turbines, wind turbines, and the conflicts between bats and wind turbines. And I'm glad that Adam spoke a little bit about it, because it puts it in your mind as I go through it. So a little bit of background, and I'm sure that hold on, let me just do something here. Sorry. Okay, so I'm sure you're all aware of the rising share of renewable energies, and wind energy is one of those sources that are becoming more and more prevalent. And I know that there are a few obstacles to wind energy in the Upper Valley in New Hampshire and Vermont, but inevitably there'll be more and more in the future. So it makes sense to talk about it, especially in the context of bat and birds as well. So as a bit of a background, wind energy production produces available clean energy. You see the asterisks there. It's because no energy that we can produce has zero effect on the environment, but compared to other energy sources that we use to power our lives, wind energy definitely is one of the clean ones. It has economic value, it has environmental value, and it has also environmental costs. And among the biggest environmental costs that wind energy has is its impact on bat and bird populations. And if we talk about bat populations specifically, then there are several aspects that make them more susceptible to being hurt or impacted by wind energy and by wind turbines, which are migration, commute. Commute is the part of day or part of night when the bat leaves the roost and goes to eat. Foraging, so the time when the bat is actually foraging, and also reproduction. Now, I'm sorry, I'm gonna just make sure, because I forgot about it now, just make sure, okay. I wanted to make sure that the sound of my later files will be audible. Sorry about that. Yeah, so those are the four aspects in bat lives or bat biology that make them more susceptible to impact by wind energy. Now, when we talk about, let's see, is it working? Working, yeah, there we go. So let's start by talking about wind energy a little bit. And we talk about clean energy and clean energy as an energy source. And over the years, more and more, we see that we are moving from a market that is completely and entirely dependent on fossil fuels to something more of a mosaic of resources. And you can see here that it changes through the year. You see the percentage of energy produced that is becoming more and more diverse, more and more renewable energy sources are entering that matrix of energies that we use for. And because global energy demands are constantly growing, we need more and more sources as we move away from fossil fuels. Wind energy right now is a relatively small, but it's rapidly growing energy source. And in some states in the United States, the energy production percentages of wind energy are pretty high. If you take Iowa, it is here more than 35% of the energy produced in Iowa is wind energy, and this is from 2017. Right now, it's much larger. I think it's more than 57% of the energy produced is in Iowa is wind energy. So it is a source of energy, clean energy compared to other energy sources, and it will grow and grow and grow. And even if right now in our area it's a little bit limited, it will definitely become much, much bigger. And so the possible conflict with bats and with birds would definitely increase. So let's talk a few words about the economic value of wind energy. First of all, as the technology, as the material improves, the cost of the energy that is produced by wind drops and makes it more competitive within the energy market. Second, it's an industry, and it's an industry that is expanding very quickly. And as the industry expands, it creates jobs, and a lot of jobs are now created in this growing market. And it can be a very wide spectrum of jobs, from the quote unquote unskilled labor. I don't like it because doing manual labor is, of course, a skill, but also to more high-end market jobs such as software engineering and material engineering. So a big host of new jobs that are being created for this industry. It also has benefit economic value because it reduces, since there is less pollution, and that is a very long-term effect. We are starting to see, or we will start to see, reduced costs associated with healthcare for respiratory diseases, cancers associated with oil, coal, or natural gases. And you can think of a lot of other economic benefits to this energy source. And besides the economic value, it also has an environmental value. And the environmental value comes first and foremost with the fact that there are no carbon emissions, okay? No carbon dioxide, nor no carbon monoxide, no methane that is being released into the atmosphere. You don't see wind energy spills. You don't see wind energy polluting underground water reservoir. You don't see large-scale destruction of ecosystems like you see in mining. And you have an added bonus is that the fact that you have a wind farm in an area doesn't mean that you cannot use that same area for other uses as well. So it could be agricultural, it could be even recreational or forestry for logs. So you don't completely convert the area into a wind farm, and you can have secondary uses for the area. So that's a big value. However, just like anything else, it doesn't come without a cost, and there's absolutely no human activity that is done on the planet today that doesn't have an environmental cost. Wind energy production is no different. And the major costs associated with wind energy production, some of them can be transient. So for example, at the time of construction, you do have a lot of disturbance on the environment. If it's cutting into the forest, if it is all the building, the noise and the shakes and the disturbance of constructing those big facilities. You have some things that can persist. For example, you have the energy transmission lines that are there forever now. You have access road, you have vehicle traffic through the environment, and that has a lot of effect over the ecosystem in which that wind facility will be situated. You have light, you have noise pollution, so those turbines are both lighted and make their own noise, and so that affects the environment as well. And for some people, another cost is that it has some sort of an effect on the aesthetic value of the environment. You can argue about that, and that's obviously very subjective, but it is there, and it is something that is being talked about. But in my view, at least, the biggest impact that those turbines have is that they cause significant mortality of bird and bat population worldwide due to collision with the rotating blades of the turbines. And just as an aside here, you tend to think about turbines as, leisurely rotating those big blades. If you measure the speed of the movement of the end of the blade, sometimes it can be faster than the speed of sound. So those are really significant, very, very high speeds, and birds and bats that collide with them will definitely be almost certainly killed. What you see in the picture here is you see on the left those griffon vultures and those red kites on the right that are being killed by this specific wind turbine farm in Spain, and over 350 of those vultures have been killed by one specific farm over 10 years, and those are globally endangered bird species. So there's a significant cost there. And the same happens with bat, probably even greater numbers. What you can see here are two American species. On the left, the hoary bat, on the right, the red bat. And if you remember from Adam's talk a few minutes ago, those are those migratory tree-dwelling species. So the hoary bat, the silver-haired bat, the red bat are the big three species that are being impacted the most by turbines because of their biology, and we'll talk about it in a second. But wind turbines definitely kill a lot of bats and birds. How much? How many? Let's talk about birds first. And the graphic I have here is actually from the wind turbine industry. So I wouldn't necessarily say that this is the most realistic number, but the estimates are that between 250 and most likely more than 500,000 birds a year die on the US alone, in the continental US alone, due to collisions with wind turbines. So yeah, it's not one of the big five anthropogenic killers. The biggest is feral cats, and then it's collision with buildings. But still, those are significant numbers, and they definitely have an effect on population, especially if this is an effect that comes on top of other things like cats, like collision with buildings, like collision with cars. And the same thing happens with bats. With bats, it's even a larger annual killer. The estimates talk about between 450,000 to 900,000 bats that die each year in the continental US alone due to collision with wind turbines. It is an anthropogenic, so man-made reason for bat mortality that is second only to white nose syndrome. And you see these big margins in the estimates, and those margins are because it is very, very difficult to count exactly how many bats are killed. Because they are so small, because they are so so hard to find, it has been a real point of debate just how many bats die each year. Even in one facility, even under one turbine, you will probably not find all the bats that are killed, even if you go every morning. And the way to quantify how many bats are killed is also not particularly easy. It's by use of dogs that are specially trained to find those bat carcasses. And if you don't get there early enough, somebody else might find that bat and that bat and eat it. But yeah, so it's very difficult to measure exactly how many bats are killed each year. Another aside here, and going to Adam's talk, what you see here is a bat, not from North America, a dead bat that was killed by a turbine. But what you see here in this part is one big blob of fat. This is a big fat reservoir. It is only about a quarter. It's going to get much, well, if that bat was alive and kept on feeding during the summer, this would get almost 3 times as large, and it will be a huge ball of fat here that the bat is going to rely on for hibernation in the winter. So it was just an aside, and I thought it was cool to show it. So that's wind energy. Now let's talk a little bit about bats, their biology and their ecology and what makes them so vulnerable. So first of all, migration. Okay, and just like Adam said, we have bats that migrate for many reasons. They can migrate to get away from the winter, or they can migrate to specific hibernacula. We have local migrations of the tens to hundreds of miles, or we can have long-range migrations of 1,000 miles or more. And all in all, globally, we have millions and millions of bats that migrate, and they migrate twice a year. And for example, one of the bats that we discussed already, that red bat, you can see the map here in purple. You can see the range that that bat is found all year round. And in green, you can see where you can find it in the summer. So these bats migrate very long distances, and they do it twice a year. And all along that way, you can have wind turbines that are waiting to slice and dice them on their way, right? So this is one significant part of their biology that puts them in danger. Another is the time when they commute, when they leave the roost and when they go to eat. And they often, many species tend to follow linear landscape elements, so just like hedgerows or rows of trees. And if you put turbines in the way, or if those turbines may resemble linear elements in the landscape, you might have a big effect on bats as they commute. And I hope you will be able, yes, you can see that. So what you can see here is bats emerging in the evening to go and feed. And this is one very famous cave in Texas, the Bracken Cave. These are Mexican free-tailed bats. And you can see just the amount of bats that are coming out, and they are all going together, and they are all usually following the same route in order to go to their feeding grounds. And if you put wind farm facility right there in their way, you can imagine what a big impact this will have on their population. So commuting, migration and commute are vulnerable times. And foraging itself can be vulnerable as well, because bats often hunt in places with high insect density, and this changes. Sometimes it changes due to wind. So the wind can bring insects to one place. And if those winds are reliable enough for bats to know this is where we go to get the insects, and those are winds that are also reliable enough to tell us humans, hey, this is a good place to put wind turbines, right? So we may create a conflict there just by choosing a place that is good for us and good for the bats. Wind turbines themselves can be an attractive element both for insects and for bats. Bats may use them for roosting. They may use them as a navigational aid. They may just come to figure out what is this thing here that I've never seen before, and so be attracted to the turbine and be hurt by it. And all in all, there's more and more evidence that is now coming to light that shows that wind turbines really does attract bats, both on land and offshore, making it a very tricky thing when we plan those projects. Another very sensitive time is the time of reproduction, and many bats reproduce by forming these huge swarms of bats, many thousands of individuals that all congregate in very specific areas to court. And we were talking about courting, and I'm going to try, and it is a little bit besides the point, but I think it's so pretty that that I wanted to share it. What you see on the bottom here is called a spectrogram, and that's a visualization of sounds that bats make. And I'm going to show play to you a courtship song of a bat. This is something that you will not be able to hear because it goes in very high frequencies. So I slowed it down, and I hope you'll be able to hear it. So because of my setup, I cannot hear it and I cannot see you, but I hope that you all heard it. And it's a really beautiful courtship song that bats often produce. And if you imagine hundreds and thousands of bats all swarming in one area, and if by some poor planning or lack of knowledge, we put a big wind farm right there, you can see that this is the potential effect on the population is huge. So with these together, where am I? Okay, so we know that we have interaction between wind energy, between bat population, and we know that this interaction is detrimental to bats. What can we do? Can we get along? Can we solve this? And luckily, to a large extent, obviously not completely, but to a large extent, yes, we can. There are many things we can do to mitigate those effects that we have. And it starts first with choosing a good location. So, for example, if we know the area, if we know bat biology, we can, before we even begin putting a single turbine, think, is this prime bat habitat? A lot of food, a lot of water, undisturbed ecosystem. Yes, maybe we shouldn't put a wind farm here. Is this a high-risk location? Are we near a roost? Are we near a hibernaculum? Are we near a swarming area? Well, in that case, maybe we shouldn't put turbines over here. Are we in a migration route? Are we near a commute flyway? If yes, maybe we shouldn't put a wind project here. So those are all things that we need to try and figure out. Some of them we can assess just by looking at the environment. Some of them we can get from the literature. Many of them we don't know, and we have to try and figure it out before we put up a turbine or a wind farm in that area. So one of the things that we can do that is by conducting pre-construction surveys. Much of the work will be acoustic. Because bats use echolocation, we can put detectors, just like this one over here, out in the environment and record their calls and try to figure out whether there is a lot of bat activity here or not. And that'll give us the first clue of whether it's a good place to put the wind project or not. So acoustic surveys detect bat echolocation. They can tell us activity patterns. They are passive, so they're relatively easy to perform. They do require expert analysis, and they do not provide us with quantities, just levels of activities, and they have limitations. For example, if we put it on the ground, we may not detect bats that are flying at 70 meters altitudes, which is where the blades would be. So we may want to put it high at the height of the nacelle, which is the center of the turbine. Another thing we can do is we can do physical surveys to search for roosts, which may be very tricky, especially if those bats are roosting in trees. But it's another thing, another effort that we should make. We can, this is another just showing you at what heights bats fly. And you have here 100 meters is a typical modern turbine, and we can see that bats can fly at those heights and even higher. So we must make sure that we record them at the relevant heights and not only on the ground. Because the mere presence of the turbines can alter bat activity, we must also do post-construction and operational surveys. So keep on with acoustic surveys, look for carcasses, and use more new technologies such as thermography, IR videography, radio tagging to figure out how bats behave around that area. And then we should also leave possibility, a legal and a regulational possibility for us to do something about it. So, okay, we have a working wind farm, and it costs a lot of money to build, and it makes a lot of money for the owner. But we found that this particular field or this particular few turbines cause a lot of mortalities that was unexpected. We should have the legal way to say, Mr. or Mrs., you have to really shut down those turbines and make sure that we don't keep killing these amounts of bats. So it's important to have those regulational tools at hand that we can use. And then one of the maybe strongest ways that we can mitigate mortality is by operational curtailment. What does that mean? When we operate the turbines, even if they are already in place. So if we take into account the seasonal aspect of bat activity, we shut off the turbines during sensitive seasons, so migration, for example, or reproduction. If we shut the turbines down during the hours of most activity, most bats will be more active in the 2 to 3 hours after sunset and in 1 to 2 hours before sunrise. So if we shut down the turbine in those hours, we can reduce a lot of the conflict and condition-dependent curtailment. So if we shut off the turbines in low speed, most bats are active in higher temperature, lower wind speeds. If we shut off those turbines there, and if you look at this, it's a theoretical graph, but bat activity is high at low wind speed and decreases as the speed becomes higher. But how much the turbine is making, producing energy, that is low at low wind energy and gets higher with the wind speed. So if we shut off during those wind speed, we shut off the turbines, we reduce a lot of the mortality, and we don't hurt much of the productivity. And just a very simple mitigation curtailment regime can reduce mortality by 30 to 60, and sometimes even 90% mortality in specific turbine, while not having more than 3% of reduction of the economic value of this turbine. So we can definitely live together, and we can also think about newer and more active ways to reduce bats. And the video here that I hope will work is from work I've done a few years ago, trying to, what you see tied to the balloons here is a little bit of a recorder that will signify a bat, and we were checking to see if we can do this. I hope you hear it. So as soon as we detect a bat next to a turbine, we have a drone coming up and doing a lot of noise, a lot of light to try and scare those bats off, which may work with some species, may actually be attractive to other species. So this is something that will not work with everybody. So I think, to sum it up, we have wind energy that provides environmental and economic benefits. We have wind energy that bears environmental costs. We have bats that are active in the sky and are very important for the ecosystems that they inhabit. And with mitigation and research, we can all live together to some extent by minimizing bat mortality and economic cost at the same time. And with that is the time for questions.
I think there's some questions that people wrote in the chat. I don't know if you can see the chat.
I could not see before, but I can now. So let's do it. So
I've added quite a bit of text to the chat too, so if people want to go through just some of the big general questions, but we should talk to some of these too around.
Photos show large-scale wind turbines, 450 feet tall tower. Aren't small-scale wind turbines less dangerous? Not necessarily, not necessarily. And Adam spoke about the fact that there are 1,400 species of bats. Some of them fly high and are more in danger of the higher turbines. Many fly low, so all the Mayotte species are low flyers, and they may very well be in danger of the lower turbines as well. And the same goes for birds as well. So it is species dependent, and unfortunately, there is no one answer that fits all. No solution that fits everybody. Is there any sound that could be played? Again, same answer. Some of the bats will be deterred by acoustic deterrents, and some will not care about it, and some will actually be attracted to it to come and see, hey, what is this sound? Do bats play an important role? Absolutely. I mean, I can talk for another 3 hours just about the how important their role is, but anything from controlling populations of insects to I mean, pollination and the seed dispersal and being food for other animals and creating their own ecosystem in the big caves that they inhabit. There, it's endless. And I think those, I covered the question. Any more questions, I'd be happy to answer.
For those of the folks on the call looking for just sort of more sort of practical information with regards to, I know there's always usually a lot of questions about bat houses and what their value is, or human bat interactions, how to deal with sort of individual bats that find their way into your home, or like the earlier questions having to do with and you know, them a slightly larger colony in your attic or something. Bat Conservation International, batcon.org, has really very, very approachable materials and step-by-step instructions on, you know, timing of and understanding what's going on and how to deal with either exclusions or individual bats and why they're using the space and a lot of that stuff. So, you know, take a look. I put the link in the chat for it, but it's batcon.org, O-R-G. The specific link is actually Bats and Homes, but they have a lot of other good practical sort of information there too. So check that out if you've got general questions about sort of the mechanics of human bat interactions, whether you're looking to do more for them on your property or prevent or mitigate issues with bats in one of your buildings.
I think Hale is raising their hand. Do you have a question, Hale?
I do, thanks. I'm wondering where I work as a forester and I work with a lot of private landowners, and I'm wondering where foresters can get more information about how to manage for bats or where to direct interested landowners. And thank you. Great presentation.
Hey, Hale, good to see you or hear you.
Hey, Adam, good to see you too.
You too.
Great job.
Yeah, so, I mean, you got a great question. You know, again, this is something that's coming up a lot, particularly with birds, bird habitat. There's the Audubon, you know, so there's the Audubon sort of organizations that nationally have turned a lot of attention to providing landowners and professional sort of landscape design and or foresters with more information on how to manage, you know, multi-storied forests and those sorts of things for birds. Bats are maybe a little slower to come along in that same realm. And again, the links again to the batcon.org, the Bat Conservation International, probably some of your primary jumping off points. It was founded by Merlin Tuttle, which was sort of one of the original sort of sort of, Walt Disney's of bats. He was just a spectacular individual who did a lot of photography and outreach and conservation and research, and has really sort of gave birth to a lot of what is sort of the popular knowledge base and platform that bats that is understood on. I mean, we have bats being argued about in Congress now because of these population declines have created monstrous pollination and pest control issues with even modern agriculture. For whether you believe or disbelieve in modern agriculture, bats have had a major swing role in that. So, Merlin Tuttle and his group through Bat Conservation International has really been the sort of the point of the spear where a lot of that information gathers. And I think it would be pretty easy to fall down a rabbit hole once you're on that site. At least I do. Whenever I get on there, I find myself wandering off into all kinds of new directions for sort of base practical information, whether it be habitat driven or otherwise. The other thing I would say is that, certainly an approach back in maybe the 80s and 90s that everything was very species focused, right? Like it was endangered species was a big thing. It was like you waited for California condors and other things to drop down to these really desperate levels and then throw tons and tons of money at bringing these single species back from the brink. Our mentality and our approach from a conservation standpoint and a land management standpoint has changed a lot. That is not an efficient way of going about conserving species. It's really about maintaining sort of healthy, what's called ecological services. It's a parcel of land, whatever size you have to work with, that is able to provide for a lot of different services that, it's healthy insect populations, healthy structure, healthy throughout different seasons of the year, the different levels. And so you're managing for a property where the web of all the energy interactions, whether it be at any level, water, plants, insects, mid-level herbivores, upper level predators, that all that stuff is sort of working together. So managing for bats really isn't all that different than managing for a healthy landscape in general. So it isn't to dissuade you from targeting specifically to look out for bats and do specific things like, try and improve habitat by leaving snags up, dead trees and those sorts of things and putting up houses. But the benefits of maintaining a healthy property go beyond, individual species focus and are able to benefit a whole host of other things in ways that you probably don't always see on a day-to-day basis. So, then that comes to the reducing chemicals, managing your invasives, and those sorts of things, which maybe are not as satisfying or not as obvious for the first few years, but have much wider ranging effects that go beyond bats into all kinds of other things.
Can I add a little bit
Please,
to that, especially now with the northern long-eared bat being federally listed? There might come some more instructions about what you can or cannot do while managing forests, as this is a tree roosting species. And I think one thing that would be beneficial to bats in general and to ecosystems in general is where possible, not necessarily to remove dead trees, not necessarily to manage the looks of an environment. And I don't know what kind of forestry you're talking about, but that's one of the
And I know the foresters in particular are under a lot of pressure right now, Hale, especially with the long-eared listing. That's the primary sort of one of the big, that certainly throws into question a lot of sort of activities that are going on. And in fact, the implementation of that has been delayed by a few months, I think largely in part because they're trying to get in place a system where the incidental take and all some complexities of a actual federal listing can be managed in sort of a living landscape like Vermont, New Hampshire, and Maine have, where logging and property management and all those sorts of things are a major part of what's going on. So it's going to be a complicated path to navigate, and to me it's another signal why we shouldn't rely on things getting all the way to the endangered listing process, because it makes things infinitely more complex. And I think it removes a lot of tools from the tool bag that if we can implement sort of these landscape level sort of knowledge and best practices before it gets to the stage of listing, things are certainly a lot easier. So I feel for the foresters in the next couple of years with the additional listings of these bats, because it's going to make things more complicated for sure.
Thank you both very much.
I think we have a couple more questions in the chat if you want to keep answering.
There's a good one there around where did the bats in the Cornish barn hibernate?
Well, I had a plan on how to check it, but like so many things in biology in general and bat biology specifically, I would proudly say we don't know. We simply don't know. Most of the bat species, definitely in North America, are too small to put long-term transmitters on. And so we can't really find out where they're going unless we know a hibernacula and we have bats that were banded and we are lucky enough to see or catch in the hibernacula a banded bat. We will not know exactly where they're going for many species. So I don't know. I have no answer. The next question, how far south do the bats overwinter in trees? How far south do they travel? So this could be crossing all of North and even into Central America, right? You can have free-tailed bats that fly from Alberta to Mexico. So a lot.
Most of our tree, I think, and for the tree bats that Eran spent a lot of time on in his talk, the hoary bat, the silvered hair, and the red bat, probably they're not going to be crossing the Gulf of Mexico. They're going to be staying Florida, Georgia, maybe even a little farther north in some cases. They're very large-bodied bats. I was mentioning the 5 to 15 gram range, but I think hoaries are upwards of 30, somewhere in that neck of the woods, right? So you're looking at a significant, almost 6 times the size of some of the small myotis. So they're relatively large bodied, and it's one of the sort of ecological quote unquote rules is that larger body sizes tend to be able to manage their temperatures better. It's more core versus less surface area. And so larger body sizes are able to tolerate cooler temperatures and temperature extremes like that. So some of these large bodied bats are built to fly, and they're built to fly long distances. And a lot of it has to do with food and stuff. But as far as temperature is concerned, they're also very furry. I mean, to use an untechnical term, a lot of the skin space that you think of bats as being, their tail membrane and their wing membranes is a lot of open, bare, naked skin. In the case of the tree bats, and you guys can go online and just go to Google and images and type in, hoary bat or red bat and get a good look at their tail membranes and stuff. They are like little woolly bears. They were just totally coated over. And it's because they do a lot of roosting out in the open. They'll hang looking like dead leaves on open branches and that sort of thing. They're very different in their behaviors. They're fascinating bats, but they are a little bit more, cold tolerant. And so they're traveling south is probably, mid-Atlantic to, north, southeast coast type areas in that neck of the range, But again, like Eran said, we're kind of in an exciting part technology wise. We're just starting to move into probably the decade that we're going to have transmitters that come down in cost and size enough that we can start getting more consistent long range sort of data coming in as to individuals and where they move. I mean, you guys have all seen mountain lion data where they travel their distances, and goats and all these other large animals that have had the benefit of being able to hang these large like D-cell battery transmitters around their neck. We don't have that luxury with some of these small bats that only weigh like the amount of a grape. So like, there's generally a 20% rule, or somewhere between 10 and 20% that we're, as a general rule, we're not allowed to put weight on a species, and particularly during a migration when they're already heavy weighted and traveling because they've put on weight and fat. It really limits our abilities to do much with regards to individual distance tracking to say this colony goes here, or even this area of the country goes to here. So yeah, there's some really cool stuff that I think is coming down the pipe, and we learn more every year.
By the way, I wish it was 20%. It's 5%.
5%. Oh, thank you.
Yeah.
Yes, yeah. Yes. Take that part out of the recording.
All right, I think that was the last question in chat. So if no one else has any questions, I think we'll probably end it here. Thank you all for coming. If you'd like to attend more workshops, next month, we're going to have a talk on climate change and a winter tree ID hike. So hopefully you guys can come to that. So thank you, Adam and Eran, for presenting. That was great. Good job. All right, I'm going to end the meeting now.
All
My
right.
pleasure. Take care,
Thank
everybody.
you all.
Bye.
Bye.